So, proteins are one of the most important aspects of living things, and it probably comes as no surprise that they're able to help us repair tissues, store energy. But what would happen if proteins stopped functioning as they usually would? Okay, wait, let me back up for a second. Proteins start off as a chain of amino acids, and each of these amino acids, such as valine, for example, are molecular compounds that are able to attract to other amino acids or to other molecules. We can think of protein folding as being influenced by three main factors. And if we were to graph these factors, we would notice that it's kind of like a ball moving down a hill until it reaches the most optimal state or structure at the bottom. The problem is sometimes when the environment changes or when amino acid sequences change, the protein might not make it all the way to the bottom of the curve and might go through protein misfolding. The problem with misfolded proteins is that they can't function properly, and the current methods we have to figure out why and when misfolded proteins occur is very complex and time consuming. However, recent research has revealed how we can use quantum Markov chains to solve this problem. Using quantum Markov chains, we can see how different environments might cause protein misfolding. Imagine our protein is in a box where we can't know its structure at all. Since anything is possible, we have to think of the protein as being in all structures at once. We can show this on a 2D graph made from our initial 3D one. Another graph shows the energy changes over time, which we'll just call the environment. If we ask the box, what might the protein look like in this environment, it gives us a probability wave of structures. One structure isn't very helpful, but if we keep asking for different scenarios, we can trace a line through the environment curve and the wave stabilizes. This final wave helps scientists see how likely a protein is to misfold in certain environments, identifying conditions that promote misfolding. Protein misfolding is linked to degenerative diseases like Alzheimer's, Parkinson's, and even liver cancer. And being able to understand how it works can help us develop treatments for the challenging conditions we're faced with today.